Tonight we're going to start with lesson 22. I can find factor pairs of numbers to 100 and use understanding of factors to define prime and composite. So here I have each one of these three sections, I have 12 dots in them. And I want to arrange them into different arrays to show 12 dots. So in this first section, I am going to pull this one down, and there is 1. Okay, I'm going to pull down another one, and that is 2. And I'm going to keep doing it, and for my array. So if you notice, I have my array, and I have 2 rows of 6 in each row. So this represents 6 because it's a row of 6 and it's in 2 groups. So it's 6 times 2, and this equals 12. So let's try another set of dots and try it a different way of organizing an array to represent 12. So I'm going to hold one down, and down here, 1, 2, and I already made 2 groups, so I can't do that again. How about we do 3 groups? And how much can we get in each group to represent 12? So now I have my 3 groups, and I have 4 in each of those groups. So this represents 4 times 3 equals 12. So that's one way of showing an array that represents 4 times 3 equals 12. All right, in our last set of dots, I already used 2 groups. I already had 3 groups. Now I need to make another group that represents 12. And this is probably the hardest. This is probably the one that we always forget. We remember 6 times 2, remember 4 times 3. But what about just making one row of 12? So now I made one row of 12 dots. Some of them get cut off because they were just so big. So what was that fact? What does that multiplication fact represent? What does this array represent? It represents 12 times 1 equals 12, because there's 12 in that one group. So boys and girls, I wanted to explain this number and this number, the 6, the 2, the 4, and the 3, and the 12 and the 1 are all called factors. Those are numbers that we multiply together in a multiplication problem. But these numbers right here are called products, because that is what we call an answer to a multiplication problem. So, for example, 2 times 3, 2 and a 3 are called factors. Now, the 5 and the 3 are called factors, but an answer to a multiplication problem is called a product. We also need to review what a prime number is and a composite number. A prime number is a whole number which can only be divided by itself and 1. A prime number must have exactly 2 factors, and it only has 2 factors. So think about 13. What can we multiply? What 2 factors can we multiply to get a product of 13? The only one that we could do would be 13 times 1. 13 and 1 are both factors of 13, and there's nothing else. So this would be considered, 13 would be considered a prime number because it only has 2 factors. A composite number is any whole number with more than 2 factors. There's that key. More than 2 factors. So if you think about the number, say, 20. We know that we have 1, we have 2, we have 4, we have 5, we have 10, and we have 20. These are all factors of 20, and there's more than 2, so that is why 20 would be considered a composite number. This next problem, they have given us 14 as the product. And we need to make a multiplication sentence, and we need to find all the factors, but we must make these factors and put them from least to least to greatest. And then we have to decide, is it a prime number or a composite number? So here's 14. So let's make all the multiplication sentences that represent 14, that equal 14. So we have a factor of 2 times 7 equals 14. And we have another one of 1 times 14 equals 14. So what are the factors? Well, we've got 2, we have 1, and a 7, and a 14 are all factors of 14. But we have to make sure that they're in order. So we have 1 that goes first is a factor of 14. 2, 7, and 14 are all factors of 14. Now, since we have more than 2 factors that 14 has, we know that this is a composite number, not a prime, because a prime would only have 2. So the factors of 14 are 1, 2, 7, and 14, and that's how we know it's a composite, because it has more than 2 factors. The next one we have is 20. So we need to list all the multiplication sentences that equal 20. So we have 1 times 20 equals 20. We have 2 times 10 equals 20. And we have 4 times 5 that equals 20. And now we must list all the factors of 20. And we want to do that from least to greatest. And then figure out if it's a prime or composite. So we have 1. We have 20. 1, 2, 4, and 5, and we've got 20 also. So now, because it's more than there's more than 2 factors, we know that 20 would be a composite number. What about 17? What about 17? Could we figure that one out? What the factors are of 17 and if it's prime or composite. So all I know is that 1 times 17 is equal to 17. There's nothing else that equals 17. That's why, boys and girls, it's so important that we know our multiplication facts. So let's list the factors, 1 and 17. Because it's only 2 factors, this would be considered a prime number. 17 would be a prime number. What about 25? Let's list all the multiplication sentences for 25. Well, 1 times 25, it's always a safe one, is 25. And 5 times 5 equals 25. There's nothing else that equals 25. And we've got to list it. So we have 1, we've got 5, and we have 25, are all factors of 25. Since it's more than 2, 25 is considered to be a composite number. All right, we got to find the factor pairs of 21 and then see if it is a prime or a composite number. So let's see. Let's start from 1. It's always the safe one. 1 times 21 is 21. And 2 times 20, well, that's no good. And then we got 3. Well, that's right. 3 times 7 is 21. That works. 4, then if we go up to a 4, we're not going to get anything else. The only factors of 21 are 1, 21, 3, and 7. And because it's more than 2 factors, this is considered to be a composite number. Julie has 27 grapes to divide evenly among 3 friends. She thinks that there will be no leftovers. Use what you know about factor pairs to explain whether or not Julie is correct. All right, so let's start drawing some pictures here. So we got this person here, and this person's going to represent Julie, and she's got 3 friends. So let's make 2 other friends. And she's got a total of 3 friends. And she only has 27 grapes. But if you look at this carefully, we have Julie and she has her 3 friends. But if it says that we have to divide it equally among her 3 friends. So that means Julie is not having any of those grapes. So we can just cross her out. So that means we're going to be taking this group here and take 27 and divide it equally among those 3 friends. So each one of those friends in the total is going to be 27. So we need to think of what pairs of factor pairs will give us 27. Well, since there is 3 friends, we know that 3 times what is equal to 27. And we know that, because we know our facts, 3 times 9 gives us 27. So she is right. There will be no leftovers. There's no remainders in this. And each one of her friends are going to get 9 grapes. So, therefore, Julie is correct. All right, give it your best shot. Give me the multiplication sentences for 10 and the factors for 10. And then tell me if it's prime or composite. Next problem is 23. Give me the multiplication sentences for 23, list all the factors of 23, and then say whether it's prime or composite. All right. Give me the factor pairs of 24, and then say if it's prime or composite, looking at your chart. Excellent job tonight, guys. You're all shining stars. See you tomorrow. Have a wonderful night.